Today, we're going to talk about a feeling that, let's be honest, we've all had. That moment when your brain just slams on the brakes and screams too much information. We're going to get into the science of why that happens, and way more importantly, how you can actually use that science to your advantage. And it all kicks off with a frustration that I'm sure is going to sound very familiar. You've been there, right? Staring at a page, rereading the same sentence for what feels like the 10th time, but the words just aren't sticking. Or maybe you're trying to learn a new program for work, clicking through endless tutorials, and it all just dissolves into a big, confusing blur. It's so frustrating, and it makes you feel like you're just wasting your time. But guess what? There's a very real, very scientific reason for that mental gridlock. It's not just you. And this right here, this is the core of the whole issue. Just picture it. All the new information you're trying to learn is like sand being poured into a funnel. See that tiny opening at the bottom? Well, that's your working memory. It's the part of your brain that's actively juggling whatever you're focusing on in the moment. And here's the picker. It has a super strict, very limited capacity. When you try to shove too much through at once, you get a traffic jam, a mental pileup. So let's really dive into this whole bottleneck idea. Because honestly, understanding its limits is the absolute first step to figuring out how to manage it. This has nothing to do with how smart you are, by the way. It's all about understanding the basic wiring of our brains, the fundamental architecture for how we learn. Okay, check out the difference here. It's kind of mind-blowing. On one side, you have your working memory. It's tiny, it's temporary. Think of it like a little sticky note on your computer monitor. It can only hold a few thoughts at once before it gets full. But then, on the other side, you've got your long-term memory, and that's like a massive, endless warehouse where you store basically everything you've ever learned. The entire goal of learning really is to successfully move information from that tiny, temporary sticky note into the permanent warehouse. So, how do we do that? How do we make sure that transfer from the sticky note to the warehouse actually happens? Well, that's where something called cognitive load theory, or CLT, comes into play. You can think of it as the official user manual for your brain's bottleneck. It's the science that helps us manage that flow of information so it doesn't just spill out, but actually gets filed away properly for good. At its heart, cognitive load theory is built on a really simple idea. Our working memory is incredibly limited. So the way we design and present information isn't just a nice to have, it's absolutely critical. If you overload that working memory, learning just stops. It grinds to a halt. The theory tells us we have to be super intentional about managing the mental effort, the load we're putting on someone's brain. And you should know, this isn't just some random idea one person came up with. As you can see here, this is a whole field of study that's been built up and tested and refined for decades by tons of different researchers. It started with John Sweller back in the 80s, and it's evolved all the way to how we design online courses today. This stuff is solid, it's evidence-based, and it works. All right, so to really make this theory useful, we have to get one thing straight. Not all mental effort is the same. Cognitive load theory actually breaks down the load into three totally different types. You can think of them as three levers we can pull to control that flow of information through the bottleneck. Okay, this table is everything. It's the whole theory in a nutshell. First, you've got intrinsic load. That's just how difficult the topic is, plain and simple. Learning basic addition has a low intrinsic load. Learning theoretical physics, well, that has a high one. You can't change it, but you can manage it. Second, extraneous load. This is the bad guy. This is all the wasted mental energy from confusing instructions, a cluttered slide, or just bad design. Our goal here? Annihilate it. Minimize it to zero if possible. And finally, there's germane load. This is the good stuff. This is the productive, deep-thinking effort that actually builds those permanent connections in your brain. This is the load we want to optimize. And this quote just nails it. The whole point is to cut out all that unnecessary cognitive burden. That's the extraneous load we just talked about. So our brains have the mental space to do the important stuff, to build what are called schema. A schema is just a fancy word for a mental framework, like a file folder in your brain for a concept. By clearing out the junk, we free up our working memory to build those strong, organized folders. Now, this is really important, so let's get this straight. Applying cognitive load theory is not, I repeat, not about dumbing down content. It's not about making everything easy or avoiding effort. It's actually the opposite. It's about making learning more efficient by making sure our precious, limited brain power is focused on the hard work that actually creates understanding, not on decoding a messy PowerPoint slide. All right, theory is great, but how do we actually use this stuff? Let's get practical. We're going to look at a few powerful, research-backed strategies that literally anyone can use if you're a teacher, a manager, or heck, even if you're just trying to teach yourself a new skill from a YouTube video. These are ways to design learning that work with our brains, not against them. This first one is an absolute game changer. Instead of just tossing a problem at someone and saying, go, you first show them a fully completed example. You walk them through every single step. Why does this work? Because it lowers the extraneous load to almost zero. The learner isn't fumbling around trying to invent a solution. They're focusing all their energy on understanding the process. They're building that mental map, that schema, which they can then use to solve the next problem all on their own.
Strategy number 2 is all about decluttering. Think about it. Every ounce of brain power a person uses to figure out your confusing layout or to connect a picture on one side of the page to the text on the other, that's brain power they're not using to actually learn. The goal is simple. Make the design invisible. Keep it clean. Keep it simple. Put related things next to each other. Don't make the brain work on anything except the content itself.
And finally, once we've managed the inherent difficulty and slashed all the distracting junk, we can focus on promoting the good kind of mental effort, that germane load. This is where the real learning happens. You do this by asking deeper questions. Ask how and why. Prompt people to explain a concept back to you in their own words. Encourage them to connect with their learning now to something they already know. This is what forges those strong, lasting pathways in long-term memory. Okay, so let's tie all of this together. When you boil it all down, what's the big takeaway here? It's really about a fundamental shift in how we think about teaching and, frankly, how we think about learning anything at all. At the end of the day, this is the most important point. Effective learning isn't about brute force. It's not about cramming more and more information into our heads. It's about being clever. It's about respecting the way our brains are actually built. Instead of fighting against that bottleneck in our working memory, smart learning design works with it, creating a smooth, clear path for knowledge to follow. And that just says it all, doesn't it? The next time you feel that sense of information overload, that my brain is full feeling, remember this. It's probably not a sign that you need to push harder. It's a signal that the way you're learning is working against you. The solution isn't to work harder, it's to learn smarter by managing that cognitive load. So I'll leave you with this question to think about. Pick something you're trying to learn right now, or maybe something you have to teach somebody else. How could you redesign that task using these ideas? How could you break it down, cut out the clutter, and focus the mental effort where it will actually do some good? The moment you start asking that question, well, you're already on your way to learning smarter,